Guys, do question 1, please. Guys, question 1, please. Alright guys, let me show you how to do this question 1. So hopefully you can do that by yourself. The idea is to show that the MGF does not exist. What you need to show is that this guy here is equal to infinity. So in other words, you need to show that the integral from 1 to infinity of this integral is equal to plus infinity, right? Okay? Can you guys see this from over this side? No? You can't see it? Oh yeah, so that's a problem. You see? Anyway, just bear with me. After I write this, I'll put this up here. Okay? Alright, I'm sorry guys. What about from the back? Can you see it? You can? Anyway, I'm sorry about it. But anyway, Um, I don't know how to put it on both screens. There should be a way to do that. But anyway, the idea is to show that this to show that this integral is equal to plus infinity. The idea is to bound e of tx by, remember what I told you. This inequality holds for every k greater than or equal to 1. Right? Guys, are you listening to me? This inequality here holds for every k greater than or equal to 1, where k is an integer. Right, so I'm going to use this inequality to bound this integral from below. So here I'm going to choose k to be, if I choose k to be 4, if I choose k to be equal to 4, this is what you will get. Yeah? Do you see that or not? If k is equal to 4 over here, then this is greater than this integral. But this integral here is simply yeah, and the integral of 1 from 1 to infinity is clearly infinity. So this is equal to infinity. And therefore we have shown that the expectation of etx is greater than infinity. Yeah? Are you guys with me? Yeah? But nothing can be greater than infinity, because if something is greater than infinity, that must imply that this implies that this must be equal to plus infinity, because nothing can be greater than positive infinity. All right, and therefore MGF does not exist. So this is how you prove. All right. Now those of you who cannot see this, I'll put it over here. Hopefully you can see this. Can you guys see this? Yeah, hopefully. So you see what I've done. I have bounded the integral for the MGF, right, by choosing k equal to 4. And the resulting integral, which is this one here, this integral here, is equal to plus infinity, and therefore the MGF does not exist. Alright, that's how you would do questions like this. Now, any questions on this, guys? You alright? Are you satisfied or not? Okay, can you do the next question? It's similar to this, guys. Can you do question 2, please? Anybody who has any Can you guys do question 2 now? Yes, come to you. Is this clear to all of you? Any? Yeah? Alright. So can you do question 2 now? You guys okay? Yeah, good. the integral of this is this, then I should check this step, please. I assume this step was correct. Yes. Yeah, yeah. Because I used the minus sign here to switch the limits around, so that when you switch the limits around, you get an extra minus sign, which cancels with this, so it becomes plus here. Is that what your question is?
When I saw like the x and the y, I get
The negative, yeah.
yeah, and I put it.
Yeah, that's why I have it here.
So then
Yeah, that's because when x equals to 0, y equals to infinity.
okay.
And when x is infinity, y equals to 0.
Okay.
All right, guys. Could you, if you haven't done question 2, let me show you how to do it. Okay. Now, again, I mean, it's a matter of choosing the k appropriately. I mean, there's no one choice for k. I mean, for a lot of problems, you can choose different values of k and they will all work, right? But not too low. In this case, I'm going to choose k to be 2. So if I choose k to be 2, this will be greater than yes? Okay, I know some of you cannot say this, but I will put this over here in a minute. All right, so this becomes yeah, yes. Now I'm gonna do the substitution that y equal to 1 over x. So x is 1 over y. So dx by dy is minus 1 over y squared. All right. You guys with me so far? So under this sub, if you make this sub into this integrand, you will get all right. When x is 0, y is infinity. When x is infinity, y is 0. This is y minus 1 over yeah. Yes. Okay, now I'm going to use this minus sign to switch the limits around. So this will be this. Now, if you were in the lectures yesterday, you should remember what this is. Do you guys remember what this kind of integral is known as? What? It's the gamma function at 0. And I remember telling you yesterday, or or the day before, that the gamma function does not exist at 0, -1, -2, etc. So this must be equal to plus infinity, right? And therefore MGF does not. Okay. Oh, sorry. Therefore, the MGF does not exist, right? So I'll put this over here if you can't see it. Hopefully, you can see this better. Is that clear to all of you? Huh? You right there? Yes. Any questions, guys? Are you okay with this or not? Yeah. All right. Can you do the next question, please? Question 3. Okay. You guys follow what I do? Yeah. Any guys quick question 3, please? Now. If it doesn't work, try 2 and so yeah, try 1. Just need to try different values of k and choose the one for which this integral becomes equal to infinity. Let's try it. Alright guys, if you haven't done question 3, let me show you how to do it, okay? So this is the integral that you need to deal with in question 3. Right, now in this case you need to do a slightly, every question is slightly different, so because you have 1 plus x here, it's better to do a sub first. Alright, so the first thing I'm going to do is to I'm going to do this substitution, y equal to 1 plus x, right? So x becomes y minus 1. Okay. You see, the reason I'm making this sub is because I want to get rid of this 1 plus x, which is kind of nasty to deal with, right? Okay, so under this sub, you get the integral from 1 to infinity Yeah. Can you guys listen, please? So this becomes now this. Hello, guys. So this integrand is it looks a lot nicer than this one, right? You see, this one looks a lot nicer than this one. So that's the reason I made this sub that y equal to 1 plus x, right? Now to deal with this integral is not difficult at all. So now I'm going to choose you see what I've done here. I've chosen my k to be equal to 2. So e of ty is greater than this term here, right? So this becomes yes, and the integral of this is you know what it is. The integral of 1 over y is log of y. Take the limits from 1 to infinity. So you have log of infinity is infinity, log of 1 is 0. So this is infinity. So MGF does not exist. Okay, is that you see what I've done here? Do you guys follow what I've done or no? So this question is slightly different because because you have this 1 plus x term in the integrand. It's better to get rid of it in the first place before making this inequality, before applying the inequality. You see? So that's the only difference in this question, right? Yeah. Okay. Are you alright, guys? Yes. Sorry. Yeah. Yeah, that's fine. That's fine. Any other questions, guys? Yes. Yeah, that's fine too. Can you now do question 4, please? If you have this question 3. Yeah, you can choose any value. Yeah, you can choose any value greater than equal to 2. Yeah, it could be 3 or 4 or any number. Yeah. Yeah, that's to infinity. That's to infinity. You guys okay? And you guys do question 4, please. questions with respect to question 3? Are you guys okay? Yeah, that's Alright guys, let's see how we can do question 4. Now, Do you guys remember what this is? Do you guys recall what this is? This is what? Something you have seen before. It's not far long. This is the log normal. It's the log normal PDF density function I mentioned in the class not too long ago. Anyway, now what I'm going to do is here. This question is a little bit tricky because you cannot choose a specific value for k that will work. So what I'm going to do is I'm going to just say this is greater than you guys listen please. Yeah, so I'm going to say that this is greater than this, but I'm not going to specify a value, a fixed value for k. I'm going to just leave k as k, right? Not choose any specific value for k. You see why I'm doing this in a minute, right? So this is 0 to infinity, 0 to infinity. All right. So this is what you get. Now the next step, because this looks like a nasty integral to deal with, when you are faced with a difficult integral, to simplify it, you can do a substitution, right? So in this case, I'm going to make this substitution that y equal to log of x. So x is e of y, and dx by dy is also e of y. So if you make the sub into this integrand, you get the following. Log of 0 is minus infinity, log of infinity is plus infinity. X to the power k minus 1 will become e of okay. So this is what you get, okay, after making the sub, right? So this becomes a little bit of simplification, gives you now. If you were in the tutorial, you guys were here last week, right? Last week, in the example class last week, we dealt with integrals like this. You probably remember, not to, right? Do you remember how we dealt with these integrals? Come on, guys. You should remember better than me. How do we deal with these integrals, guys? Alright, the first thing is I'm going to pull out the minus a half, so it becomes y squared minus 2 ky dy. The second thing is I'm going to do something that I did last week. I'm sure you do. Can you tell me what I have done from this line to this line? Something I did last week. What have I done? Huh? You were here last week, weren't you? What have I done from this line to this line? completion of squares. So it's completion of squares. Okay. All right. Now I'm going to pull out this constant term outside the integral, so this becomes yes. Now, if you look at this thing here, the thing I have highlighted must be equal to 1. I mean, this is the same trick I applied last week. You remember that if you are integrating a PDF, then by definition it must be equal to 1, right? Now what you have here is the PDF of a normal distribution with mean equal to k and variance equal to 1. Okay, so therefore the integral of it from minus to plus infinity must be equal to 1, right? This must be equal to 1. So what you are left with is and this approaches infinity as k approaches infinity. So hence the MGF is this clear, guys? It's a little bit involved, but can you see what I've done, guys? Any questions, please let me know. Is that clear for you? Yes. You guys okay? Question 5 is trivial. You should be able to do question 5 by yourself. You should have no problem with doing that. Okay. Alright guys, I'll see you next week. If you have any questions, about the post, please come and see me. I'll send you. You guys are okay? You have any questions? No questions?
Oh my god, look at the board.
Um,
I use maths, so it makes sense.
so I know, look at the size of it. It's just crazy, isn't it? Oh, God. This is what?
So my sister's a maths teacher, she teaches A level. She said, no, classroom now she's got boards all around the room, so like you can get kids up and be like, right.
We had that at
And
uni.
it's just put aside.
Well, we had whiteboards, like, there's like 6 in the classroom.
Yeah.
And we used to do a lot of group work on that. It's alright, I suppose it's more interactive and stuff.
Yeah. As opposed to like making the kids
It's-
up in front of everybody.
Yeah, it's different than like just traditional Socratic where it's here and let somebody talk and you answer questions.
Yeah.
No, I definitely prefer it here. I just don't like the fact that we're on the
Yeah. See, I'm working with both now. Laptop for workshop, notebook for lecture. That's the wrong notebook. Oh no. Oh no.
Yeah,
That's
sorry.
what it is. Can't write in the wrong book.
Because I remember one yours broken. Like laptop.
Yeah, the new laptop is
Yeah.
probably like gone. My laptop was ancient, like the 16th birthday can be at the other day. Right, what are we doing? Right, laptop is I'm like writing in my notebook. It really upset me.
I feel that.